Hello friends, welcome to the class of operating system. Today we will be studying about the various scheduling techniques, or what do you understand by the process scheduling. So in our topic of processes, we'll be studying about scheduling technique. So today we'll cover up about what is process and why process management is so important as a part of function of operating system. As we know that the function of operating system, the four main function of operating system are the process management, memory management, file management and device management. So if we are talking about process management, how actually the system is going to work? What are the criteria that needs to be taken care by the operating system when it is going to manage multiple processes in a system? As we know that what is operating system? Operating system is a system software which acts as an interface between user of a computer and computer hardware. So the user is going to interact with the application and the application is going to interact with the operating system, and the operating system will actually interact with the hardware, and it is going to provide us with the interface so that programming and all the other activities of computing is much easier with the help of operating system. So here you can see there are various operating system. Various types of system is going to have various types of operating system. Mobile operating system are different, desktop operating systems are different. So if we consider the process, as we are going to emphasize on processes, as we are going to emphasize on how it is going to manage the process, we should understand why do we require this process. So what is process? Process is the program in execution. So our system is a multi-programming system. Multiple program can execute at a time, and the processor is going to switch among the processes. So the user, like for example, if you are going to work on a system, you will not just work on one application at a time. You will be working on various applications. Like at one place Word is open, simultaneously you are going to check out on the social networking site, simultaneously the web browser is open, simultaneously for example PowerPoint. So you are going to work on multiple applications. Now if the multiple application is being carried out by the system, how actually it is going to manage? What are the kind of things that needs to be taken care of? That we will study today. So in the process concept, you need to understand that what are the processes, and in a system, in a multi-programming system, multiple processes can be executed simultaneously. The switching of the processes is so quick that we will be thinking like processor is dedicated to a single task, but a single processor will be switching among number of processes. So the process is the program in execution. So process is the active entity and the program is a passive entity. There will be number of applications in your laptop, but whatever you are executing, double clicking and opening it, that becomes the process. So process is the active entity and program is the passive entity. So process is the program in execution. And for making it easier, the process is being divided into section. So first is the text section, which is the program code. Text section, which is the program code. Program counter is your current activity, because once the process is executed, the CPU can switch to different process. So if it is going to switch to different process, the current activity of the previous process should be saved properly. So that is nothing but the program counter. Next will be the process stack. Process stack is the temporary data. Temporary data like your function parameters, like your local variables that you are going to use in your program, that is the process stack. Next is the data section, which contain the global variable and the heap memory, that is the dynamically allocated during the process runtime. So in the process, there are four main sections you are going to understand. That is a text section, that is the program code. Next is the process stack, that is the temporary data. Next is the data section, that is your global variable. And the heap memory, that is a dynamically allocated during the process runtime. So this is the way in which the process is been stored in your system. Now, if the process is been executed, it may happen that CPU, if I am going to use the word CPU and processor is the word I am going to use it simultaneously. So, if a process is been executed, now as the process has been executed, the condition will not be like CPU will execute the complete process at a time, then it will switch to another process. It will not be so. So it may happen that while executing a process, a higher priority process comes, or whatever process the processor has been executing, it requires some kind of IO operation. So if it requires some kind of IO operation, the CPU is not going to sit idle. So if it is not going to sit idle, then it is going to switch among the job, among the other process. So what are the stages through which the process move? So that is a process state. State of a process is defined in the part by the current activity of that process. So here you can see there are various jobs in this system, various programs that are the new. When it is brought in the main memory, it comes to a ready state, means it is ready to execute. There are various processes, for example P1, P2 and P3 and so on, they are in the ready state. Now the processor will select the process from the main memory. Now that will be done by the various scheduler that will be studying in a further lecture, how it has been selected. So the processor will take one process and it will execute. While executing the process may require IO operation, it may require some kind of resources. So and that has been carried out. So IO operation is much more slower than the processing of the processor. So in such case, processor is not going to sit idle. It will switch to other process, and the process which was executing moves to the waiting stage. It will switch to another process and another process will execute. It may happen that processor is executing a process and some kind of interrupt happen. Some kind of activity happen that the processor needs to pay attention to. So in such case, the switching may happen. So that is it moves to the waiting stage. And otherwise, if the process has been executed successfully, then it will be terminated. Otherwise, some kind of problem happens, then it will be terminated in an abnormal manner. So these are the process state. So you can understand that a process may be in the one of the following state. That is a new. New is the process has been created. Ready, the process is in main memory and it is waiting to be assigned to a processor. If the process has been executed, then it will be in the running stage. If the process is waiting for some kind of IO operation, then it will be in the waiting stage. So this is the diagram for the different state of a process. Next is the scheduling. That is why do we require this scheduling? So what is scheduling? Scheduling is the process of process manager handling the removal of the active process from the CPU and selecting another process based on the specific strategy. So in actual, what is process scheduling? the process is being executed by the CPU, but the active process is been removed from the CPU and another process is been given to the CPU for execution. Why this happen? What is the reason behind this? What is the algorithm that is being used? That everything will be covered in the process scheduling. Like some kind of operating system might implement first come first serve. Some kind of system might implement the round robin technique. Some kind of will implement the preemptive time share system. So in the process scheduling, what actually happens is a CPU will not be dedicated to a process for a whole time. It will switch among the process. And why it is going to switch? What is the reason? Why other process has been given priority? So it takes a various criteria and then the decision will be taken by the system. So the main purpose of the CPU scheduling is to make the efficient use of your CPU, is to make the efficient use of your system so that your system is faster and every process gets the equal fair to execute. Now, for example, we'll take that one process P1 is there and it require 10 millisecond, and another process P4 it require only 1 millisecond. So P4 is not going to wait until P1 will execute. So what technique the operating system imply to execute various process will differ. But the main purpose of this process scheduling is each and every process in the system should get the equal fare to execute. There should not be any kind of starvation to the process, and the efficiency of your system should be at the maximum. The utilization of the CPU should be at the maximum. So everything will be covered in this process scheduling. So what is the objective of process scheduling? That is, the CPU should be used at the maximum level, because if the process is doing some kind of IO operation, as I have already told, that IO operation is much slower. At that moment the CPU is not going to sit idle, it will switch to another process. Then allocation of the CPU should be fair. Higher priority process should be given time. It doesn't mean that lower priority process will wait indefinitely for execution. So allocation of the CPU should be fair. The throughput, that is a maximum number of processes that can be executed, should be maximum. The turnaround time, this time taken by the process when it enter until it exit, that is a turnaround time for a process should be minimum. There should be minimum waiting time for the process and the minimum response time. That is, the time when the process produces the first response should be minimum. Time taken should be minimum. So when we consider this kind of various criteria while studying various process scheduling algorithm, we need to take care of all this stuff. So one by one we will study about various process scheduling algorithm, and we'll calculate the throughput time, we'll calculate the turnaround time, and then we can come to conclusion that which of the scheduling algorithm is fair. So whenever the process is going to switch among the processor is going to switch among various processes, there are various kind of queue which play a very important role, and that are, the first is the job queue. The job queue contain all the system processes. Next is the ready queue. These maintain the list of processes in the main memory which is ready to execute. Like ready queue, you can imagine it as a ready state. In ready state, all the processes are ready to execute. Similarly, all the process which is ready to execute are placed in the ready queue. And the queue which is made up of the processes that are been stopped owing to the lack of the IO devices. they are in the device queue. Though all the processes which require the IO operation are placed in the device. So here you can just take a view of what is job queue, ready queue, and once it is ready queue, it will be executed by the CPU. While executing, it may require some kind of IO operation. Then if it requires, then it will be placed to the IO waiting queue, and then it will be given the IO devices, and then again it will be placed in the ready queue, and then the circle moves. It will be executed by the CPU. If the operation is done, then it will be terminated. So your process scheduling algorithm, your system can be of two types, preemptive and non-preemptive. And in the preemptive there are various types, in the non-preemptive there are various type of scheduling algorithm. What do you understand by preemptive? What do you understand by non-preemptive? In non-preemptive means the process are executed only after the current process has completed its execution. Non-preemption means if the process P1 is executing and P2, a higher priority process, comes in, then to first P1 will execute, then only the switching will be done. That is the non-preemptive. Okay. Non-preemptive means it will take one job, it will execute that job, then only it will switch to another job. So here the concept of priority will not be coming, because the priority scheduling comes under the preemptive. Okay. So non-preemptive means once the process will execute, whatever process which is taken by the processor will execute that process, then only it will switch to another process. So the process hold the resources of the CPU till its state changes to terminated. Till it terminates, it will hold on the CPU resources, or is being pushed to the process waiting state. Then only it will be, the CPU will be freed. Otherwise, it will complete the processing of the current process, and then the process is been executed, then only it will switch to another process. That is, it is not interrupted till it is completed. So that is the non-preemptive. System will not preempt the execution of the processes. That is the non-preemptive scheduling. Again, in non-preemptive scheduling, a new process is executed. There will be number of processes, P1, P2, P3 and P4. P1 is going to require, for example, 10 time burst, and P2 require only 1 time burst. Still, first P1 will execute, then only P2 will execute, because this is the way of working for a non-preemptive scheduling. The processes which is holding the processor will execute that process, then only it will switch to another process. Whereas in the preemptive scheduling, there are various facts which is taken care of, like for example priority. That is, the higher priority, if the process is executing some kind of process and some higher priority process comes in, then the CPU will switch its execution from that particular process to the higher priority process. That is the preemptive scheduling. So if the interrupt occur in the system, then it will switch among the processes. That is the preemptive scheduling. So I hope that concept of today's lecture is been understood. That is, what is the process, what are the process concept, how it is represented in memory, what are the various state of process, what actually does process scheduling mean, what are the objective of process scheduling, what are the scheduling queues, what are the types of process scheduling, what do you understand by preemptive and non-preemptive. So thank you for watching the lecture. If you like my lecture, kindly like, share and subscribe to my channel. Thank you.